to put all of our trigonometry together and take a look at solving right triangles. Now, a question that says solving a triangle rather than just solve for a part of a triangle means that we have to figure out everything in the triangle. So anything that we're not given, we need to find. So once we're done the question, we know all three sides, we know all three angles. Example number 1, we have some given information. Anytime we have a question like this, we want to create our triangle first. We want to draw our triangle. Now, I just noticed as well that we are missing angle A here, which we should have, which is 42 degrees. So first thing we do is we draw our triangle, and we do notice that we have a 90-degree angle in here. So we do know it's a right triangle. We know that we can use SOHCAHTOA to solve this. So drawing our right angle triangle, angle C has to be at the 90-degree angle. Doesn't matter whether we put A or B at the other two corners as long as we label it appropriately. Remember, angle C is opposite to side C. Angle A is opposite to angle A, and angle B is opposite to side B. Our angles are denoted with capital letters. Sides are denoted with the lowercase letters. So we know how to decipher whether we have an angle or a side. Looking at this triangle, we know that C is our 90-degree angle, side B is 2.5 meters, and angle A is 42 degrees. So we need to find everything here. The easiest thing to solve for right now is angle B, and remember we can do this because we know that all three angles in a triangle have to add up to 180. And we called this ASTT, angle sum of a triangle theorem. So that's the reason that we know this. And sorry, getting a little ahead of myself here. We're subtracting our 42, which means that angle B is 48 degrees. So now we still have to find side A and side C. Well, looking at if we want to solve for side A first of all. So let's take a look at side A. Side A is opposite to our 42, and we know our adjacent. So we know that we're going to use tangent. So tan of 42 is equal to side A over 2.5. To solve for A, we're going to take our 2.5 over and multiply by tan 42. And we're going to round this to one decimal place. We know that we get 2.3 meters for side A. Now we can figure out side C. Now, side C is we always want to try to use our given information if we can, because we know it's correct. We know we haven't had to round anything. So we're going to still stick with our 42-degree angle. C that we need to figure out is our hypotenuse, and we know the adjacent. So we're going to use our cosine of our 42-degree angle is it's going to be our adjacent over our hypotenuse, which means that it's going to be our 2.5 over side C. Bringing side C over to the other side, and we know we can't solve for it on the bottom, which is why we bring it over to the other side. And we can kind of do two steps in one here in taking our taking our C over to the left. We're also going to bring our cos 42 over to the right. So 2.5 divided by cos 42, and here we get 3.4 meters. Now, for this step, we could have used Pythagorean theorem because we know two sides of our triangle. The only issue is that we rounded this one, which is why it's better to use the given information here. We know that this is more precise than using an answer that we rounded. If we had to use the version from over here, the answer from over here, we could keep more decimal places, either way. Now, because we did a whole bunch of things here, we want to sum up what we did in a therefore. So we found angle B is 48, side A is 2.3 meters, and side C is 3.4 meters. Okay, so just summing up everything that we did there. Part B. Again, first thing we want to do is draw our triangle. We do know that we have a 90-degree angle, so we can still use SOHCAHTOA here. And we know that angle Q is our 90-degree angle. Our other two sides we can choose to put where we want as long as we label appropriately. So side R, opposite to angle R, is 3.2 centimeters. Side Q, opposite to angle Q, is 5.3 centimeters. So we need to find angle P, we need to find angle Q, and we need to find side P as well. So we can find side P here. We know that A squared plus B squared equals C squared. So we can't forget that we do still have Pythagorean theorem if we know two of our sides. So we want to solve for P, meaning we're going to take our 3.2 squared over to the other side where it becomes subtracted. And we're going to put 5.3 squared minus 3.2 squared, and we're going to square root that. We can do that all in one step in our calculators, rounding to one decimal place because we're solving for a side. We get that P is equal to approximately 4.2 centimeters. Now we have a couple of angles that we want to find. Angle P. So if we want to use angle P to start with, again, concentrating on our given information, we know that we have our adjacent and our hypotenuse, so we're going to use cos of angle P. We know that it's 3.2 divided by 5.3, and we're going to find angle P by doing our inverse cos of 3.2 divided by 5.3, which means that angle P has to be 53 degrees. Again, rounded to the nearest degree. And angle R then can be found by taking 180 minus our other two angles because of ASTT, which means that angle R has to be 37 degrees. And again, we're just going to sum up what we figured out here, putting it all together so that anybody taking a look at our solutions can see very quickly what we figured out here. Okay, so that's solving for our triangles, just finding everything that we don't know right now. A couple of definitions that you're going to need to know are angles of elevation and angles of depression. So first of all, angles of elevation. Remember that elevation simply means up. So if we're talking about angles of elevation, we're talking about the angles from our eyesight, horizontal, looking at something in the sky. So we could be looking at a plane, we could be looking at a cliff, anything that we're looking up, and our angle of elevation would be from the horizontal up to whatever we're looking at. So our angle of elevation is from the horizontal up to what we're looking at. Now, if we're talking about angles of depression, remember depression just means down. So now we are up top, or whoever is looking at this is up top. So angle of depression again is from the horizontal, so straight across where we're looking, down to whatever is down here. So we could be in a tower looking down at something. We could be on a cliff looking down at a boat. So if we think about a cliff and a boat, now that's from the horizontal looking down to the object. So our angle of depression is actually outside of the triangle here. But we know that if this is the horizontal, this is also the horizontal, and they're parallel, we can also know that theta is down at the bottom inside our triangle as well. If we're doing a question like this, we have to label it up at the top to start with, recognizing that this is our angle of depression. So example number 2, we are looking at from the top of a fire tower, the angle of depression of a forest fire is 27 degrees. We want to find the distance from the tower to the fire if the tower is 175 meters high to 1 decimal place. As always, first thing we do is draw our triangle, draw what it is that we know here. So we know our angle of depression, which as we mentioned is outside of the triangle from the top of the cliff or the top of the tower up here looking down. Our tower is 175 meters high. We assume that anything like a tower, a building, is always creating a 90-degree angle with the ground or the horizontal. So now we know that this angle in here is also 27. And what we want to know is the distance from the fire to the tower. Well, we always say let x represent. We always want to say what the variable is. So the distance from the tower to the fire. Now, we look at given angle. We know our opposite. We're looking for adjacent. So we're going to have to use tangent ratio. So the tan of a 27-degree angle is going to be equal to 175 over x, taking our x to the other side and our tan 27 to the other side as well. And when we put that into our calculators, we find that x is equal to 343. We're looking for a side, so we round to 1 decimal place, 343.5. We have the answer. We always want to have a therefore statement stating what the variable means, what it means to our situation. So the fire is 343.5 meters from the tower. Okay, so there's different parts to a question like this. We have absolutely, first of all, our diagram. We have our let statement, our setup, our solution, and we always want to finish off with our therefore statement as well. Example number 3, this time the angle of elevation, so looking from the bottom, looking up to a plane in the sky, is 25 degrees. Always diagram first. And angle of elevation is 25 degrees. We know that the horizontal distance from the person down here looking up to the plane. So the person to the plane is 2,500 meters horizontally, straight across the horizontal. And what we want to figure out is how high is the plane. That's what our let statement is going to say. Let x represent the height of the plane. And again, looking for which ratio we need to use. So we are looking for opposite. We have the adjacent. So we're going to use tan again. So tan of 25 is equal to x over 2500. Taking our 2500 to the other side, we know that 2500 times tan 25, putting that into our calculators and rounding to 1 decimal place for a side, means that the plane is 1,165.8 meters high. Okay, so again, a little bit more trigonometry, putting everything together, setting up our diagrams if we don't have one, and making sure that we have our proper formatting of word problems as